we're going to talk about lesson 51 and specifically talking about graphing linear equations. In order to do this, we're going to look at a couple equations that they have as examples first, these two at the top. These are examples of linear equations because all of our exponents and our variables are to the first power. Or as we talked in our last lesson, they're first degree terms because our x's and y's aren't squared or cubed or anything like that. That helps us show that these are linear equations, or when we graph them, they're going to be a line. We oftentimes like to write our equations when we're going to graph them in what they call standard form, where our y is on one side of the equal sign and our x is on the other and any other portion. So usually we have a number in front of our x, or coefficient in front, and then we have an extra number at the end, and that's our b number that we have here. We're going to do some examples that the book gives us that are already written in standard form. I just wanted to introduce that because now we're going to see it often written like this. If we had equations like this, we would move them around until they became this form. But for now, they're just going to give them to us in this form to begin with. So what we're going to do first is look at some x values that we can plug into this equation and solve each for y. So we're going to do 5 different ones as our example. So this is essentially creating 5 different problems that we need to solve. So we're going to write this equation 5 different times, plugging in each of these for x. So our first example is if we plug a 0 in for x, I'll rewrite that exact same equation, and it's important at this point to go through these steps and rewrite the whole equation, plugging in your 0. So when we solve, 2 times 0 is 0, and we'll just rewrite our -1. And so in the end, 0 minus 1 equals a -1. So since we solved and found that y equals -1 when we plugged our 0 in, we can write our -1 in this box. So I went through each of these, and I'll show you all 5 of them. So when I plugged in a 2 for our x, and I could have plugged in a 1, but I'm just going in with the ones that the book randomly picked. But they plugged in a 2, so that's this 2 right here. So I'm rewriting the same equation, just putting a 2 in the place of the x. And to solve it, first I'm going to multiply. So 2 times 2 is 4, and I'm just rewriting that -1. And the last step is 4 minus 1, which equals 3. So it looks like you're writing a lot of steps, but it really helps keep things in order because as we're dealing with some negatives coming up, you can make little errors pretty quickly if you don't write everything down. So since we found y equals 3 here, we plug it in our little box here. If we plug a -2 in for x, when we solve this problem, 2 times a -2 becomes a -4. Again, we're rewriting our -1. -4 minus 1 is a -5. So again, we're dealing with a lot of different negatives, so it's nice to write it all out. So we enter our -5 here. The next one, when we plug a 3 in for our x, we go to this equation. 2 times 3 is 6. We write our -1, and 6 minus 1 equals 5. So I plug a 5 in to this box. And our last one is a -3. Again, the book chose these kind of at random. I might have done a 1 or a -1, but it's just showing you could use almost any number you want. You just don't want it to be too high of a number, so you don't have to draw too big a graph. So when they put a -3 in for x, right here, 2 times a -3 is a -6. Rewrite our -1. -6 minus 1 is a -7. So we put that in that box. Then over here on the side, I just rewrote all of these into actual ordered pairs. So my 0 for x resulted in a -1 for y. So we would write that as the ordered pair 0, -1. And I rewrote each of these. So 2, 3 is written over here. -2, -5, and then 3, 5, and -3, -7. So now we have 5 different points to plot. And as you can see, the first little axis I drew, I've decided, since I'm dealing with some kind of bigger numbers, a -7 is probably the furthest number I'm getting away from the origin, I want to have plenty of space. So I'm coming down here and I drew a little bit bigger axis. So I made sure I can draw at least up until 7 points going in each direction on this graph. And again, I rewrote all of our points we want to graph. So the key in graphing again is looking at your x value, and I'm going to label our x-axis and this vertical axis as our y-axis so we don't forget. And we're always going to remember it's x comma y. They always go in that order. So our first number is going to tell us which way we're going on the horizontal or left-right axis. Since it's 0, we're not going to go left or right. We're going to stay right here. But since our second number is a -1, that's our vertical or up or down movement. So if it's negative, we're going to go down 1 space. So I'm going to make a nice point right there and kind of small next to it. Just write that ordered pair so I know what I'm labeling. The next one is the point 2, 3. Again, the 2 is our left-right movement. Since it's positive, I'm going to go to the right. 2 points. I'm not going to draw a dot right here because I'm not done. Now I need to go up 3 because it's positive. So I'm going to go 1, 2, 3 points up. So I'm going to be approximately right there. Again, without graph paper, it's not super accurate, but it can get pretty close. And again, as we graph these, hopefully we're going to see that they're going to form a line and not be scattered around. So I've graphed this one and this one. Now I'm going to graph -2, -5. So the -2 again is my x value. So I'm going to go left 2 because it's negative. So this is -2. Then I'm going to go down 5 because this is negative. So I'm going to go 1, 2, 3, 4, 5. So it's approximately right here. So we've graphed this one. Now we're going to do 3, 5, moving to the right 3, and then up 1, 2, 3, 4, 5. So I'd say approximately right there is the 0.35. And our last point is both negative. So first our x is going to start at -3. And our y is going to be -7 all the way down here. And as you can see, we've graphed all these points and it really does look, and it's nice if you can get out a little bit of a ruler here to kind of draw your line right through. So this line, if I label it, is the line y equals 2x minus 1. This is the equation for this line. And again, if we had plugged other numbers in for our x, we would have just found other points that lie on this line. So that's one example of graphing a line. If you look in your textbooks, it will show other examples. And the thing to keep in mind, we used 5 different points here to graph this line. But technically speaking, you only need 2 points to show a line. But it's nice to do 3 because 3 points sort of confirms you know that they're all straight in a line. Because if you just have 2 points, it's easy to make a mistake. And then the last part that this lesson 51 discusses is graphing vertical and horizontal lines. So if we're going to graph this line, x equals -2. Again, usually when we graph something, we have an x and a y. So if we only have an x, that's a little signal to us that it's not just a normal line that's going to be graphed with x and y values. This is saying x will always be -2. So to graph this, you remember which is your x-axis and y-axis. It's always good to label them. And I'm going to go -2 on my x-axis. And if x is always a -2, it's going to be a -2 no matter what y is. So even if y is 0, y is 1, 2, 3, 4, 5, 6, 7, or negative numbers, doesn't matter what y is, it's going to be always a -2. So whenever you have an equation that's just x equal to something, it's going to give you a vertical line. And then if you're given, let's say you're given y equal to something. So it's a little different because now we don't have an x value involved. So now y will always be 4, no matter what the x value is. Again, I'm going to label my axes. So if y is always a 4, I'm going to move up to 4 here. So even if x were 5, y is still going to be 4. Even if x were 1 or whatever it is, no matter what x is, y is always going to be 4. So I'm going to draw a solid line on y equaling 4. And so anytime you have y just set equal to something without x's involved, it's a horizontal line. And then sometimes what they like you to do is they might give you 2 equations that they want you to graph on the same chart. So I'm going to show you their example. If they give you this equation, which involves a y and an x, so now we know that's not horizontal or vertical. That's going to be doing something else. And then just y equals 2. We'll start with the y equals 2 because we already know y equations give us a horizontal line. And we're just going to start it right at 2. And I'm going to put arrows on the end of my line to show that they go infinitely. So this line is y equals 2. To graph the other line, we need to create our little box. So we're going to do some x, y values. And we need to do at least 3. And I'm going to do 0, 1, and 2, just to pick some pretty easy ones to plug in. So when x equals 0, y will equal 0 times 2, which is 0. So we're going to just put a 0 in there. When x equals 1, then y equals 2, 2 times 1. And the last one, when x equals 2, y equals 2 times 2, which means the x is 4, or y is 4, excuse me. So now we have these 3 points, 0, 0, 1, 2, and 2, 4. So to plot the number 0, 0, it's right there at our origin. Then we're going to plot 1, 2. 1 is our x value. So we're just going to move 1 to the right, and we're going to move 2 steps up. So this one happens to cross right there. And our last point, let me label this one, is 2, 4. So we're going to move 2 on our x-axis and up 1, 2, 3, 4 on our y-axis. So this creates a more diagonal line. And again, I could write more ordered pairs to kind of confirm my line, but I can see the line it's creating there, and I can go ahead and draw through it. So this horizontal line was our y equals 2. This diagonal line is our y equals 2x equation. And you can see they cross right there. So those are just some examples. Look in your book if you want to see some other examples of graphing equations.